This video is sponsored by GarageFarm.net. I think we can all agree that there is nothing quite like a well-kept patch of grass. It is just so mesmerizing to look at, and if you're a 3D artist like me, then there's just something really satisfying that just makes you go like, oh man, I wish I could make that. Well, it's easier than you think, and today I'm gonna show you exactly how it's done. Welcome to the world where nature meets technology, and dive with me as we unravel the secrets of crafting the perfect grass simulation in Blender. And here's a twist. It's not merely creating a static field of grass, that's already been done. We're taking it to the next level, and we go all the way from shooting seeds onto the ground, then we watch them sprout into a proper meadow, and when they are all done, you can even give it a trim. By the end of this journey, you will be able to grow life from the ground up, one blade at a time. So get ready to blend reality and imagination like never before. And if you already like what you see and you wish you could play with it yourself, you can head over to my Gumroad and you can grab the blend file there. Link in the description. As you can see, the geometry nodes tree is absolutely enormous, and I kept those pockets of nodes in frames instead of groups on purpose, because this way I have a better overview on what's going on, and the frames are doing a great job separating different functions in this tree. So in order to be able to digest this thing, we have to separate it into more manageable parts. So the whole setup, as you could see in the intro, consists of mainly three parts. We have the seeds that are being spawned and shot into the air, and as soon as they land on a surface of our choice, they stop. Then they start growing exactly one grass blade per point. And finally, when the grass is all grown up, we have an opportunity to trim it with an object of our choice. Plus, there are some minor things along the way that have to be done, but those are the main points. So let's start with a plane, a sphere, and an empty in our scene. The sphere is gonna be the spawner for the seeds, the empty will be the target for the seeds to fly towards, and the plane will be the surface for our grass to grow, and also it will hold the geometry nodes setup itself. I strongly recommend naming everything as we go along, for example like this, because it can get pretty messy real quick. So let's split the window into two, open geometry nodes in here, and click new to get a new geometry nodes tree. Let's start by dragging the speed spawner into our geometry nodes setup. And for the point spawning, we can just use the points node. Now keep in mind that the amount of points we have there will be spawned every single frame, so be careful with that. Then we also need a random value and a bounding box node. So the points will be spawned randomly within the bounding box of our sphere. Make sure that the object info node is set to relative, and the most important, that the seed of the random value node is connected to scene time frame. This ensures that each frame we will have a point spawned at a different random position within our bounding box. Now we can frame this up and name it like a professional that I'm sure we all are, and also not to get lost in the nodes later on. To make sure that we can actually see anything happening on the screen, we will need to pull up a simulation zone and connect our points via join geometry node just like this. And for now, we don't really need a group input, so we can leave it disconnected. Now we should have points spawning within the bounding box of our sphere, and to make it shoot towards our empty object, we need another object info node and then calculate the vector between the sphere and the empty. Luckily we have just the node for it, so let's just pull up a vector math, set it to subtract, and subtract the sphere's position from the empty position. The order of operation here is important because otherwise the points will just fly in the other way, so if that's the case, then you did it wrong and, well, try again. Now if you tried to test this, it would be quite crazy because the speed of the seeds would depend on the distance between the sphere and the empty, so in order to make sure that the velocity stays consistent, we need to pass it through a normalize node, which is actually just a vector math node set to normalize. Now this we can directly plug into our simulation zone. Remember that everything in the zone is done once per frame, so in order to move our points every frame, we need a set position node and plug our velocity setup into the offset. We can also throw in another vector math set to scale in between to be able to easily control the speed of our seeds. Now, if you did everything correctly, you should have points flying towards the empty object with the speed of your choice. But if you play with it a little bit, you can see that because the velocity stays the same all the time for all the points, weird things begin to happen when you move the empty around while the simulation is still running. So here comes one of many attributes that we will need to store throughout this whole video and then reuse it in the graph. So first, let's capture the velocity of the point as it is being spawned. So let's pull up the store named attribute node and plug it over here and give it a name velocity. Now change the type to vector and plug in the calculated velocity towards the point into the value. Now because we have this attribute stored, we can bring it up anywhere in the graph through a named attribute node. So let's bring it in here and again change it to vector because that's what our velocity is. And the name is also velocity. Small tip here, if you let the simulation run for a bit from the start, then the stored attribute will show up in the list after you click the empty field in the named attribute node. Otherwise, you have to make sure that you type the name correctly. Now you can take this named attribute and plug it directly to the set position offset node. And this should now make the points to be shot in the direction of the empty and also keep their velocity even after the empty is being moved. Now the points move in a linear fashion, so in order to improve it even further, let's give it a little bit of dampening and maybe some gravity. In order to slow down the points over time, we need to update the attribute every frame, so let's duplicate this store named attribute and put it into the simulation zone and plug it right after set position. The name stays the same because we want to update the same attribute over time. Now right after the named attribute, let's bring a vector math, set it to scale and scale it by, let's say, 0.99. And then the result goes into both the set position as well as the store named attribute value. Now each point's velocity is decreased a little bit every frame until it comes to a halt. Well, actually it never really stops because each frame it's 99% of the previous velocity, but who cares? Now to make sure that the seeds have some gravity and they actually fall on our plane, let's add another vector to it, and this time the last value, the z-axis, let's set to a minus 0.1, and that is the fake gravity that we can control with this value. Now let's get all those nodes and click Ctrl J to add them in a frame, and this one is the velocity plus gravity. Now let's make sure that the points actually stick to our mesh once they land. So actually let's bring a join geometry node right before the group output and connect group input into that so we can actually see our plane. Now to make the points actually stop on the surface, we need to check how close they are to the surface and then bring their velocity to 0. So let's get another group input, geometry proximity node and a position node, so that we can calculate how far away from the face of our plane is each point. Now add a color ramp and connect it to the distance, and that we can multiply with our velocity calculations. You can simply use vector math scale for that. Also, let's make another frame and call it stop at the surface. Now, if you go to the side view, you can see that as the points are landing on the plane, they slow down until they completely stop. And we can change the color ramp interpolation to constant to see that even better. And now the color ramp white value controls the margin in which the point are considered grounded. You can play around with it and see what works best for you. But as you can see, if the margin is too small, some points go through simply because they move too far in between frames to even register that they were close to the surface of the plane. One thing you can do to help it is to increase the frame rate in your render tab and then adjust the velocity of the points as well as the gravity. But you can also just ignore the seeds that fall through, and if you need more of them, just spawn more points. And the ones that fall through, well, we don't have to care about them because they get deleted anyway, so problem solved. Now this part is pretty much done, and at this point you should have a functioning setup of shooting points and landing on a surface. If for some reason this doesn't work for you, then you probably missed a step or two, so watch this part again, and everyone else, follow me. The next step is get your mouse and hover over that big red button under the video, and once you are there, just smash that subscribe button and who knows, maybe even like the video and enable notifications if you're feeling generous today. Don't let me stop you, you know? Now with that out of the way, we can get to spawning our grass blades. But before we can do that, we actually need the grass blades themselves. So you can either do what CG Geek did recently and go outside, take your camera, take a couple of photos of the grass blades, spend some time in the sun and then bring it all into Blender. Or if you enjoy sitting in your basement like me, then just go to Google Images and look for grass blades and choose something that you're happy with. I can guarantee you're gonna find plenty of that. After that, just import the image into Blender using images as planes and change the name of the object to grass. Small disclaimer, if you don't have import images as planes in your Blender, go to Preferences, Add-ons, look for images as planes, and you have to enable it there. And if you can't see anything, just a gray plane, you can go to this Viewport Shading options, and under Color choose Texture, so that we can see what we're actually doing in the viewport. Now duplicate it however many unique blades you want to have, and then go to Edit mode, and while in Edit mode, first let's go to Options in the upper right corner, and tick Correct Face Attributes. Now whenever we move the vertices, the texture will actually stay in the same place and won't get stretched. Now all there is to do is add some loop cuts using Ctrl R and then move the vertices around until you have every single grass blade cut out on a separate plane. Something like this. Now before we move on, lastly, let's select all the grass blades, because we need to adjust the pivot point. So with the blade selected, go to Options and select Origins. And then position the pivot point somewhere in the bottom of the grass. Now do that for every single grass blade, so later on we won't have any problems growing it. And also make sure to press Ctrl A and apply rotation and scale. We can also grab all the grass blades and add them to a separate collection to keep the scene more organized. So with the grass selected, hit M to create a new collection and let's call it grass. Now back to our geometry node setup. In order to spawn the grass from our seeds, we will need few things. First of all, an instance on points node, a collection info node, and a 2 random value nodes. We connect it with our main setup like this. The collection is the one holding our grass blades. Just make sure that the collection is set to relative. Both separate children and reset children is checked. And also in the instance on points node, the pick instance is checked as well. That's very important in order to have exactly one grass blade grow from one seed. And the random values are here just to randomize the rotation and scale of the singular blades. I recommend using those values for both rotation and scale, but feel free to experiment with it as you please. Maybe, who knows, you will find some more interesting results. And if you additionally wanted to respect the angle of the surface, in case that your ground is not perfectly flat, I have a special tip for that later in the video. For now, we can frame it all up, and this is the instantiate grass blades on points. Now as you can see, we have points landing on the surface, but the grass is already grown since the beginning. So we need to delay the growth until the seed is no longer moving, and plus we can add some custom offset that we can control later, in case we want the seed to have some sort of delay. And now a big shout out to Ben from the channel Cartesian Carmel for this amazing tip, because well, without him this video probably wouldn't happen. So big thanks, and if you like geonodes then you would definitely like his content as well. So first of all, we will need to add another stored attribute to monitor the seed age, which will start counting once the seed has touched the surface. So let's get another store named attribute, and this time it's gonna be an integer, and the name is seed age. Now in order to calculate that, we will also need a couple of named attribute nodes, 3 to be exact, an equal node, a math node set to add, and a switch node. Now what we do here is we want to check if the velocity equals 0. Also make sure that it's set to element-wise, and the epsilon is the margin of safety that we can also give to it. I will have it set to 0, but you are welcome to experiment with what works best for you. And then we want to use that result as a switch. So if the velocity is indeed 0 and the point is stuck to the surface, we want to take our seed age and increase it by 1. And if it's false, meaning the seed is still flying through space, we want the seed age to stay the same for the point. And the result of the switch goes right into the store named attribute value. And now to make this have an effect on our setup, we will need to spawn the instances only on points that have the age equal to whatever number we decide. This is where you specify the delay, or rather the incubation time of the seed if you want to sound professional. So let's get a named attribute with our seed age, and using math node set to compare the age with, let's say, 5. And epsilon set to 0, because we only want the seeds that are 5 frames old to bloom. And now, when you play the simulation, you may notice that the seeds, yes, land, and the grass blades indeed pop within 5 frames from the landing, but they also disappear the very next frame. Because the seed, well, the age is no longer 5, so in order to make them stay, we will need another simulation zone. And the same as with points, we want to use join geometry to combine the existing grass blades with the ones that are popping up. And that should give you the results that we are going for. So now the seeds land, we get grass blades popping up, and they also accumulate over time. Now, as you can see, the grass pops abruptly, and in order to smooth the growth of the grass blades, we will need yet another store named attribute. And with it, we want to track the time of the grass in the growing stage. So let's bring in store named attribute in here, right after the join geometry. And this time, because now we are working with instances, we need to change the domain to instance instead of point. And the value type we can leave to be float. And let's call it grass growth. Now this is fairly simple. Every frame we want to add a value to it, and by this amount the grass will grow every single frame until the value gets to 1. And why 1? Well, I will get to that in a second. So now in order to use that attribute outside of the simulation zone, let's bring in a scale instances node, which is gonna facilitate the growth for us. And we also want a named attribute node, a color ramp, and a combine XYZ node. Let's connect it like this. Make sure that the named attribute is our grass growth, and the X and Y value in the combine node is set to 1, because we only want our scaling to be done on the Z axis. And we can plug that right in the scale instances scale. And here in the color ramp you see that the values go between 0 and 1, and we can also define the way the grass will grow. So if I, for example, bring another color stop and change the interpolation to B-spline, I can arrange it in a way that will make the grass grow quickly at the beginning and slow down the growth over time. And that is the second part of the tutorial. Now in the last part we will get an extra object to run through the field and cut the grass for us. So first of all, we have to realize the instances, because in order to trim the grass we will have to actually delete the geometry. So we don't want to simply scale the blades down, we actually want to cut them. Also, now is a good place to put a set material node where we can choose the material that was created for us when we imported the images as planes. If you want more advanced material setup, then you can either get the blend file on my Gumroad and support me in this way, or you can talk to me on Discord channel and I'm sure we can figure it out together. Link to both is in the description. And if you are wondering why first we apply material and then we cut the geometry, think about it as a hair salon, where first they color your hair as it is and only after they do the cutting. Same thing here. So after that we can finally place the delete geometry node. However, in order to know which geometry to delete, we will need 2 more attributes to store to determine that. Firstly, let's go to our second simulation zone and put a store named attribute there. Again, set it to instance, and let's call it grass cut. Now let's create new mesh on the scene, which is gonna be our lawn mower. Let's say it's a cube, and you can make it a bit smaller, change the name to grass cutter, and make sure to again Ctrl A and apply rotation and scale. Now let's drag it into our geometry nodes like this, and add a geometry proximity node, a color ramp, math node, and a named attribute node with the same name, grass cut. Now again make sure that the object info node is set to relative, and connect it to the proximity node like so, and the proximity distance straight to the color ramp. And all that let's add to the current grass cut attribute, so that once our lawn mower moves through an area, the grass stays cut and it doesn't regrow right after. Also, to visualize what is going on, we can spawn a few grass particles with our grass cutter object nearby. And if we preview the color ramp output with Ctrl, Shift and left mouse button, again, disclaimer, if that does not work for you, then you have to go into Preferences, Add-ons and enable Node Wrangler in there. And as geometry input in the viewer, let's choose the Realize Instances node. Now you should see the mask that the object is gonna spread around the grass, and the color ramp controls how far from the object will the grass get cut. Now let's just delete the viewer node, and this can go directly into the store named attribute value. And once we have that, we can go to delete geometry node and with named attribute set to grass cut, we can plug that into the selection. And that should make the grass that's passed by our cube disappear. You can test it out by simply moving the cube through the grown grass, and if it doesn't really work for you, then again, you probably missed a step or two, so feel free to just rewind, go back and check it out. Now you can see that the grass is being deleted completely and not simply trimmed, so let's tweak that part a little bit. Again, we will need a store named attribute, and let's plug it right before the scale instances node. Name it zGradient, because that's what it's gonna be. And here we won't use any fancy math, it's just a position node connected to separate XYZ, where the Z value goes right into the named attribute value. That will give us a gradient from the bottom to the top of our grass blades, which we can use to only trim the tip. So let's go to where we delete our geometry and bring in our named attribute zGradient. Pass it through color ramp for better visual reference to what's going on. And then math node set to multiply and multiply the color ramp with the grass cut attribute. And now that goes into the delete geometry selection. If you preview the color ramp output here, you can easily adjust how much of the grass blade will be cut. Now keep in mind that the accuracy of this gradient depends heavily on the actual geometry of your grass blades. For example, if the grass is just one polygon, then it won't work because there is no geometry to be deleted. But also don't make the grass blades too dense, because then the scene can get laggy real quick. Now as a bonus, for all of you that made it this far, couple of quality of life improvements to this setup. So first of all, we can use a noise texture to make the grass look a little bit more interesting. So let's also get two vector math nodes and set one to be subtract, where we subtract 0.5 on each axis, and the second will be scale in order to control the strength of the noise. Now we can insert a set position node right here and plug our noise results into the offset. Now by playing with the noise texture, you can see how we can distort the grass blades themselves. Now we can also make it so only the higher parts of the grass gets distorted, using our Z gradient if you want. And additionally, if you want to give it some movement, all you really need to do is change the noise texture from 3D to 4D and plug in the scene time frame divided by some number to the W value. The divider then will control how fast the grass moves. The higher the divider, the slower the grass moves. And lastly, as I promised, if you want to have the grass grow on a surface that's not perfectly flat, like for example, let's put a slanted wall in here, then you will notice that it will anyway grow upwards because, well, that's how the grass blades are oriented in the 3D space. So if that's not what you're looking for, here is how to make them respect the surface angle. For that we need to go back where we instantiate the grass on points. See? That's exactly why it's important to name stuff along the way. And now we will need group input, normal, position, sample nearest surface, that's set to vector, and also an align Euler to vector node. We connect it like this, so on the surface of our geometry, we want to sample the normal vector, so the one perpendicular to our surface, and the results we need to run through the align Euler to vector so that the instance node will understand the rotation correctly. And now we could plug that directly in and it will spawn the grass according to the surface angle, or we could mix it up with the original upward angle to make it a little bit more interesting. So let's get a mix node, set it to vector, and plug our random value and the normal rotation in there. I like to keep the factor at 0.5, but if you move it around then you can get more influence from either of the inputs. And done! Oh, and last thing, because I'm sure you find the points as annoying as I do, so if you want we can either not show them at all by just breaking this connection. The setup will still work, but you just can't see the points and where they're going, so it's harder to debug what's actually happening. Or we can delete them after they lived their lives, and we get to decide how long is that. So we can get a delete geometry node in here, a named attribute node, and a math node. The named attribute we are looking for is the seed age, and the math node let's set to greater than. And in here we specify how old the seed gets to be and delete all the older ones. Just keep in mind that the delete age should be higher than the delay grass spawn age that we specified here. Otherwise, the seeds will just die before they get the job done. And congratulations, because that is basically the meat and potatoes of this grass setup. Now, the project file you can get on Gumroad is a little bit different. It doesn't have any secret knowledge that I didn't share here, but it's like this except on steroids. So if you wanna support me, then this is the way. It has a few more features and a well set up control system to make it really easy to operate. And actually I can show you some of it. So as you can see, I have this sample scene setup with basically all the elements that we've done in the tutorial, but I also have quite a few elements that you can control straight from the modifier geometry nodes. It just makes the whole setup way easier to operate. And if we click play, you can see that I also animated this the target so that we have our grass being spread out fairly evenly around the plane. And as I mentioned, the setup is fairly performance heavy because we are dealing with tons of geometry. And the denser we want the grass to be, the heavier it gets. As you can see, I'm already at 11 frames per second, and you can also specify the frame range within which the grass will be spawned, so that, I don't get accidental blue screen when I'm working on it. Which is why for this video, I decided to collaborate with GarageFarm.net. And GarageFarm is a cloud render farm that connects directly with Blender. They have their own add-on, and that just makes the process super easy to work with. And even if you have any problem, they do have a support team that's available 24 hours, 7 days a week, so I'm sure you'll be fine. But best, let me show you how it works. So you can see that in this scene, if I want to render this out, maybe we can also take our grass cutter object and run it through the simulation, maybe from this frame. We add a keyframe location, and then by the end I want it to be actually out of the frame. So again, location. Now we can test it out with much smaller number of seeds just to see if the animation works fine in the viewport. And since everything seems to be fine, it's time to bake the actual animation. So I will increase the number of seeds to something like 1000, just to make sure that we have a really nice, dense patch of grass in here. And we can also check out the rendered view, because I've used some basic HDRI for the environment and textures from Polyheaven for the ground. The grass texture I made myself the CG Geek way. I actually went outside and took some photos of the grass outside. So in my Gumroad file, you will get the grass texture, but not the ground texture. So now that I have the number of seeds increased, 1000 seems a bit like an overkill, but we will see how it goes. Then now I need to go into the physics tab, delete the current bake, and make sure that I bake the simulation before I even try to render anything. And while this is baking, you can use the link down in the description that will take you to the GarageFarm.net website, and I will show you how to set it up. So on the website, you can already see that if you're a Blender user like me, you can enjoy this nice 33% discount when you're using Blender for rendering. And additionally, you can get $50 of free credits when you start free trial. You don't need to connect your credit card or any payment information. This is $50 free credit, no questions asked, and you get all the features that the website provides. So to set it up, we start with Start Free Trial. That will take you to a screen when you have to make an account on the website. I already have an account because I rendered all the animations from the intro that you could see in this video using GarageFarm, so I will just log into mine. But then as soon as you log in, you can probably see the same screen as I do. And the first thing that you have to do is go to Downloads, and then depending on your operation system, you want to download the client, which is gonna handle all the uploading of your scene to GarageFarm, as well as downloading the results to your computer. Even though I've already done it, I will do it just to show you the installation process. And also you can see that other than Blender, they also support 3ds Max, Maya, Cinema 4D, basically all the big names in the 3D space. Now the installation is very straightforward. You just go through, click next, just like any other software. Also in the middle there is going to be part where you have to specify the folder in your hard drive where you want your results to be downloaded to. And after the installation is completed, now we get to install the Blender plugin. So just hit install. You will be prompted to close the Blender window, so let's do that. Make sure to save, and then we can close it. Retry. And then you have to find where on your computer the Blender is installed, and then you select the exe file of your Blender. After that installation is completed, we can see that the status is installed. So now we can open our Blender file again. Remember how we baked the simulation? That was very important because now we don't have to do it again. The simulation is already baked, so we can just jump to, for example, this frame. And that's how it's gonna look like. I'm not gonna try to render a single frame because I already know what's gonna happen. It's just gonna crash the Blender. But luckily that's what services like GarageFarm is for. So now let's go to Edit, Preferences, Add-ons, and we want to look for Render Beamer. And just make sure that this is enabled. It should be enabled by default, but in case it's not, this is the add-on that you're looking for. And now we can actually export it to animation. So before that, make sure that you go to File, External Data, and then Pack Resources. Because we want to make sure that all the simulation is packed inside the blend file that we will upload to GarageFarm. And after we pack all the resources, we go to Render, Render Beamer, and then Beam It Up Animation. You will get prompted with a warning that will basically tell you that you should render a test frame before you submit the whole job. So we just click OK. The scene is being prepared, and then we can open the render beamer. As you can see, it's uploading to GarageFarm, and the size is almost 4 GB because of all this simulation data that we packed into our blend file. And now once the file is uploaded, we can just click here to submit the job, which is gonna open the garagefarm.net website. And here we have a couple of options to set. So as you can see, I'm using a test job at the moment, which is gonna render 23 frames with this camera. I have only one on the scene, so I'm gonna choose that one. The samples, maybe let's limit it to 1024. The resolution full HD is fine for me. I will use PNG, but you have multiple other extensions that you can use. EXR, for example, if you want to color grade it later. But for me, PNG is fine. And one thing that I really like about GarageFarm is not only the price is really cheap, like on the baseline, you get also 33% discount when you're using Blender. But additionally, you have the priority option here. So you can either choose to be high priority job, which is gonna cost you more, but at the same time, it's gonna happen faster because there's gonna be more machines dedicated to you. Or if you want to save some costs and you're not really that pressed in time, you can simply choose low cost, which is so much cheaper. As you can see, like the high is 1 cent and the low is 0.3 cent. So I'm gonna choose this one, and then we can simply submit the test. Now you will see your project in here with a cost of successful rendered frames, as well as an estimate, which is gonna happen later after it already renders few frames. And here you can also see the priorities. So the high priority currently has 0 jobs in queue. So if you submit yours, you're gonna go directly into rendering. But because I submitted with low priority, there's already 9 jobs in there waiting. So I have to wait for my turn, and then I will get to render my frames. So I'll get back to you once it's done, and then we can look at them together. Now, after the job is done, you can see that all 23 frames were rendered. Now, the frames should download automatically on your computer in your specified folder, but in case they didn't, you can always go to the client on your PC, switch the tab to Downloads, and then hit Refresh, which is gonna download all the remaining files. In my case, all 23 files are downloaded, so we can just open up the folder, and we can look through all the renders to check whether there is any artifacts happening or something. So as you can see, it looks quite fine, in my opinion. So everything seems to be working perfectly. So if we are happy with the test render, we can go back to the website and double click on the job, and then switch from test job to full job. which is gonna render all the remaining frames, so you can actually combine it into an animation. All the other settings stay the same, and then we just click submit. So let's wait and see how long it's gonna take to render the whole 450 frames. And even though currently we are rendering on GPU, GarageFarm also has an option to render on CPU. You can see that there is different jobs queue, so you can use it to your advantage and use whichever has less jobs submitted, which means your render is gonna come up faster. And what in my opinion is the biggest plus of services such as GarageFarm is the rendering actually happens in the cloud. So the 100% of computation power of my PC is for my disposal. So I can either work on another scene, I can watch a movie, play a game. My computer is 100% usable while I just wait for results to be downloaded. Now, after all the rendering is done, we can just go to the client, downloads, refresh, and as you can see, all 450 frames are downloaded, and we can see all the files in our download folder. So now everything that's left to do is just combine it into animation and enjoy. As you can see, the rendering quality is perfect. So again, big thanks to GarageFarm.net for sponsoring this video, and the link in the description is gonna take you guys to the website where you can start free trial with $50 worth of credit for free right now. And I will see you in the next one.